I'd like to introduce Ruben Keller, who is the Henry Chandler Cowles Lecturer in Environmental Studies here at the University of Chicago from 2009 till 2011. He is a community ecologist who focuses on the impacts and management of invasive species. Most of his research deals with the traits of species that make them capable of entering new regions and becoming prolific. This work leads to predictions of those species that are likely to become invasive in the future, which in turn can be used to inform management efforts. Most of this research is applied to freshwater systems with a concentration on invasive species in the Laurentian Great Lakes region, which is where we are now. Dr. Keller collaborates extensively with economists so that the ecological and economic impacts of invasive species can be considered when management efforts are devised and implemented. After earning his PhD at the University of Notre Dame, Dr. Keller held research positions at the University of Cambridge and then at the University of Notre Dame, where he edited the book Bioeconomics of Invasive Species. He has worked extensively with various management agencies, including the City of Chicago, Indiana Department of Natural Resources, and the U.S. National Invasive Species Council to incorporate invasive species science into management programs. Please join me in welcoming Dr. Ruben Keller.
Hey, thank you very much for having me. My talk, we have until 11. I imagine that I'm going to take about 30 to 40 minutes, so there should be plenty of time for questions at the end, but I'll also take questions along the way if you have any. Can everyone hear me, and do I sound roughly normal? Whatever that means. Okay, so my talk is a little different from the other talks you'll be hearing in that I'm talking more specifically about biology instead of engineering or sort of higher level social impacts of the way that we deal with fresh water. But what I want to convince you of today is that invasive species are a serious problem in and of their own right, and also that invasive species interact very strongly with many of the other issues that you're hearing about through this Teacher Institute. So my talk is titled Human, Ecological and Economic Impacts of Freshwater Invasive Species. And I've put my email address there. That's the best way to contact me. I'm happy if any of you want to get in touch with me later today by email, although I'll be around all day. But at any time in the future, feel free to contact me with any questions that you have. So as an overview of what I'll talk about today, I'm going to begin by talking about the invasion sequence. Then pathways of introduction, that's the ways that non-native species are introduced into freshwater ecosystems, the different ways that species can become invasive and cause harm. I'll talk about patterns of freshwater invasions over time, and then talk more specifically about some case studies where I'll try to link more explicitly freshwater invasions to some of the other topics that are being spoken about. So first of all, the invasion sequence. And this has been quite a large advance in the way that ecologists think about invasions. And it's occurred over the last couple of decades. And it's recognizing that to become invasive, a species has to pass through at least 3 steps. So obviously it begins as a species elsewhere. And that would be a species that's in its native range. We then call that species introduced. And there are many synonyms for introduced. It might be alien, exotic, non-native, but I'll use the word introduced today. We call it introduced if it's transported beyond its native range and into a non-native range. For that species to then take the next step towards becoming invasive, it needs to become established. And it becomes established if it escapes, so if it's no longer being cultivated in some way by humans, and if it begins reproducing. So it's self-propagating now. It's become its own particular force, creating its own population. That's an established species. And then finally, to become invasive, the species needs to begin to spread and to cause harm. So it needs to move beyond its original population in the non-native region, so it's spreading and it's causing some sort of harm. And of course, harm is a pretty slippery term to use here, because harm is something that is very difficult to ascertain without putting your human values on it. And that's really how we define harm, as invasion biologists as well. if a species is causing harm, then it's somehow impacting negatively human values. So that might be economic harm, ecological harm if it's affecting native species that we highly value, and there's harm to human health as well, which I'll talk about. So these are the steps that a species needs to pass through to become invasive. And to summarize that definition, Bill Clinton did it very nicely in his Executive Order 1311-2, which was put out at towards the end of his administration. But this executive order defined an invasive species as an alien species whose introduction does or is likely to cause economic, environmental, or human health harm. And I'll talk about each of those categories of harm as we move through. So the first question to ask is, well, how do they begin moving through this invasion sequence? So how do species become introduced? And the really big picture of species introduction is that it occurs because of globalization. Because we as a society are now so intensely and intimately connected to many other societies, indeed most other societies around the world. And we like to travel from the Midwest to the Pacific Northwest to Europe to Africa to Australia. And when we travel, we can carry propagules, and propagules being spores or some sort of living material of these non-native species. And we also like to trade with all of those other societies. We like to be able to buy bananas from Costa Rica. We like to be able to get our mangoes from the Philippines and things like that. And all of these different pathways, these ways that we're moving people or goods or equipment, means will they open up opportunities to also move species. And those can be live species, they can be seeds, they can be fungal spores, they can be viruses and pathogens. So it's really globalization that has created the problem of invasive species. And if we look at that in a little more finer scale, these species can be introduced either intentionally, so we can meaningfully introduce them, or they can be introduced unintentionally as some sort of a byproduct of other activities. And I'll talk about that distinction now. And I'll also begin talking more specifically about freshwater invasive species. So we have many, many intentional ways of moving these species around. And this is one of the things that I spend a lot of my research time thinking about, is the ways that we move these species around. So for aquatic organisms, the water garden trade in the Midwest has been increasing massively over the last decade, and it's based mostly on non-native species of plants and animals. If we put them in our backyard pond, then usually these species are very good at reproducing. That's what life does, and we get more of them than we originally put in there, and perhaps more than we want, and those might then find their way to the local pond or the local waterway, because we need to get rid of them in some way. Likewise with the aquarium trade. The bait trade is a wonderful way of moving species around. We catch them in one water body, we move them to another water body, and inevitably some of them escape. Aquaculture is one of the fastest growing sectors of the food economy, and that is also largely based around non-native species being moved around, and so on. So we have many, many ways of intentionally moving these species around. And to go into a couple in a bit more detail, historically, one of the strongest pathways has been the intentional stocking of fishes and crayfishes and occasionally mammals to create new fisheries for sport or for food. And one of the best known examples of this is the introduction of the Nile perch into Lake Victoria in Africa. So Nile perch is this very aggressive, rapidly growing fish. They get to be just enormous. And people like to eat them, especially Europeans. So the idea was, well, let's introduce Nile perch into Lake Victoria. It will create this new fishery, which will create jobs. It will create protein for societies that are very protein, or that were desperate for more protein in their diet. And what happened was that it was a spectacularly successful experiment, I guess. The Nile perch took off. They got to enormous quantities. in the lake. But they've also become strongly invasive because Lake Victoria contains this incredible, what's known as a species flock of cichlids. It contains about 400 species of recently diverged cichlid fish, which are highly prized by aquarium keepers. Nile perch loves to eat cichlids. So there have been on the order of 200 to 300 species of these cichlids that have been lost as a result of the Nile perch invasion. So it's had some positive effects. It has created this fishery, and some people make a lot of money selling this fish to Europe, but it's had these severe negative effects as well. We introduce species, as I said, through the aquarium, live food and bait trades, and many of the invasive aquatic species that we have in the Great Lakes and in this part of the world have come from those trades or have been further spread by those trades after they arrived. And I mentioned the water garden trade as this very powerful pathway for bringing in new species that are already adapted to living outside, and then they can be released. So those are intentional pathways. We also have very many unintentional pathways. So these are pathways where we don't specifically set out to move a species, but our activities, our other sorts of activities, unintentionally move them around. And one of the ways that, or one of the types of species that are moved that is most concerning to us, and that it should be most concerning to us, is the transport of disease and pathogens. And I'll talk more about cholera as an aquatic invasive species in a couple of minutes. We also move species around accidentally because we're not very good at identifying them in a lot of cases. So we think we're introducing one thing, but actually we're introducing something else, and that something else is a dangerous invader. We move things around, and this is a particularly powerful pathway in the Great Lakes, in the ballast water and on the hulls of ships. Things get moved around through canals and as contaminants of intentional species. So perhaps, and anyone who's had an aquarium may have had this experience of buying a new batch of plants from your aquarium store, and all of a sudden you have a snail problem in your tank because those plants came with snails. And those snails, in turn, are very easy to release because we don't want them in our tank, so they tend to find their way out, and they can become more invasive species. So some more specific examples. I mentioned that the Great Lakes have been heavily invaded by organisms that have come in on ships. So these large intercontinental ships, which can now enter the Great Lakes because we've dug canals so that these ships can make it past the Niagara Falls into the upper Great Lakes, they're engineered and they're built to travel at a certain level in the water, and they need to be at that level for safety. So if they're fully laden with cargo, they're designed to sit at that level. But if they're not fully laden with cargo, they'll sit higher, and they need to compensate to bring them down to that safe operating level. And the way they compensate is by taking on what's known as ballast water. And they have these large ballast tanks in their hulls. So they take on ballast water at some port, somewhere else, and then they travel across the ocean, and they enter the Great Lakes, and perhaps they pick up more cargo in the Great Lakes, which means they no longer need that ballast water, so they dump it out. And those tanks can actually be, they're not great places for an organism to survive, but they can be quite acceptable. These crayfish carried with them this pathogen that was released into European systems where the native crayfish have no natural resistance. So you then have this situation where the invasive American crayfish are moving through the European systems, and not only are they outcompeting European crayfish, they're sending forward these fungal pathogens which are killing off the crayfish. So we have this invader with its own sort of associated invasive fungal warfare sort of a system. And that's obviously an unintentional pathway. And the Europeans are spending many millions of dollars at the moment trying to slow the spread of this pathogen. Okay, so those are how species are introduced. And then we have to look at the invasion sequence again to think about how these species move through the sequence. And what is it that means that some species move through while others don't? And if you notice in my figure here on the left, the thickness of the arrows decreases as you move through the sequence. And that's my little sort of graphic way of representing that there are lots of species elsewhere. A lot of species get introduced. Not that many of those introduced species become established. and very few of those established species become invasive. So it's interesting as an ecologist, it's an interesting question to ask, well, what makes some species move through while others don't? And what we know, and we know more than this, I'm pleased to say, but we still don't know that much, but the things that we know for sure are that species are more likely to go from introduced to established, so to make that step in the sequence, if they're introduced multiple times in high numbers. So that's not too surprising. If you give them a lot of chance to become established, they're more likely to become established. And also if their habitat and climate requirements are closely matched in the new ecosystem. So again, that's not too surprising. If you move something from temperate North American freshwater systems to temperate European freshwater systems, it's more likely to survive and become established than if you move something from the Bahamas to Sweden, for example. And the next step in the process is from established to invasive. Again, these species are more likely to become invasive if they have a close habitat and climate match. But there are a few different things that come into play here. They're more likely to become invasive if they're adapted to dispersal by humans. So if they're some way more likely to be moved around by humans. So we might think about aquaculture species as being well adapted because they tend to be large and fleshy. Humans like to eat them. Humans are going to move them around. We want to have them in more places than just one. And species are also more likely to become invasive if they're adapted to living in human-modified habitats. And I'll talk about that a bit further on in relation to invasive species in dams. But generally, because it's humans who move these species around, they're likely, when they turn up in a new environment, to be in a human environment that has been modified by humans. So if they're well adapted to that sort of environment, they're more likely to establish and become invasive. That's why we see species like rats and pigeons that are so ubiquitous across the world now, because they are extremely well adapted to living in cities with humans, whereas the native species in the US are less well adapted. Apart from, there are some that are quite good, like raccoons and possums, but rats and pigeons are generally the kings of living in close proximity to humans. Okay, so that's how species arrive and how they can move through the invasion sequence. I'll now talk a little bit about the impacts, which is sort of why should we care about these invasive freshwater species. I've already spoken about how species like the Nile perch can be introduced and compete with and predate native species. In the case of the Nile perch, we've seen the loss of somewhere between 200 and 300 species of cichlid. And this funny sort of a spaghetti blotchy diagram in the bottom right, this is a way of representing the diversity of cichlids in the African rift lakes genetically. And what I really wanted to show, which might not be so obvious because they're small photos, but is that across the bottom here we have these 4 photos of cichlid fishes, and these have evolved to look very different and to have very different functions within lakes like Lake Victoria. But they've all been, a lot of them have been wiped out by the Nile perch. So within that lake, it's not as if we've just lost one small part of the ecosystem, one small part of the community by losing these cichlids. We've actually lost a very large range of functional types of fish. So fish that eat mollusks, fish that eat other fish, fish that eat invertebrates, fish that eat algae. They're all bound up in this cichlid family. Other ecological impacts are that invasive plants can overgrow lakes and rivers. We see that a lot here in the Midwest. People spend a lot of money on herbicides trying to knock out these plants. We have non-native pathogens and diseases that can affect native species. And invaders can actually decrease water availability, and I'll give a good example of that a little bit further along from South Africa. Economic impacts of invasive species. Invasive freshwater plants tend to be one of the most expensive types of species to control, and they're problematic because they can overgrow a body of water, which can make it very hard for the native species to survive there. can be very expensive to get rid of them, and it can also affect recreation. No one wants to go and fish or go boating on a lake that's covered in an invasive species. We lose fisheries, such as the cichlid fisheries in Lake Victoria due to invasive species. And it's estimated that the total annual costs to the United States economy from all invasive species, so this includes terrestrial invaders as well, so invaders on land, but it's estimated that that's about $120 billion. So that's a really, really large impact. You can spend a lot of time fighting in Iraq and Afghanistan for $120 billion. But this is sort of a recurrent cost to the United States. And one of the poster childs for economic impacts is the zebra mussel, which you may have heard about. It was originally introduced to the Great Lakes. It moved through the Chicago canals into the Mississippi River. It's now out west in some of the canals that the previous speaker was talking about. And they're now actually having to use chlorine in a lot of those canals on a roughly daily basis to try and kill these zebra mussel, because they pose such a huge threat to the water treatment and water distribution facilities out there. In the Great Lakes, its largest impact is that it gets into nuclear power plants, which have to shut down for a couple of weeks at a time, which is a huge impact. You don't just flick a switch and turn off a nuclear power plant. It takes weeks to close it down and weeks to start it up again. But they get into these power plants, and you can see in the photo here that they basically grow to completely impede water flow through these pipes. Then we have the human health impacts of freshwater invasive species. So most human diseases and parasites are invasive. If we think about a disease like SARS and the way that it emerged in southeastern China, but very quickly spread as an invader around the world. And a good example of a freshwater invader is cholera, and this is actually spread around in the ballast water of ships. So there was a cholera epidemic in Central and South America during 1991 and 1992, in which over 500,000 people became infected, and there were roughly 5,000 deaths. And it's believed, no one knows for certain, but the best explanation for how this epidemic began is that it was introduced in ballast water. A ship came in with a large dose of cholera in its ballast tank, released that ballast water into a port where it was able to enter the water systems and then begin its transport through people. Invasive species can have large impacts on food availability because they can eat out crops. And we see this especially with rice, and there are a couple of particularly nasty snails that get into rice paddies, which are essentially manufactured aquatic ecosystems. You get these snails in there, they eat up a lot of the rice. This can lead to food shortages, which are particularly acute and damaging for people who are subsistence rice farmers. And invasive species can also be vectors of human diseases, and I'll talk about some of that further on as well in the case studies. So it's interesting now to look at, well, what are the patterns in freshwater invasive species? Are we getting more of them or less of them over time? And the answer is that wherever people have looked at this, which is really only a handful of places around the world, but wherever people have looked, the rate of arrival of invasive species is pretty well correlated with economic activity. And that's to be expected because they're largely driven by these processes of globalization. So I looked at this with some collaborators for Great Britain. We looked at the number of freshwater established non-native species over time. And you can see we're able to go back as far as 1800. And over time, we have the intentionally introduced and the in black and the accidentally introduced in grey. And you can see that this is increasing at an increasing rate. That is, we have an exponential rate of increase in the number of species over time. And we now have this situation in Great Britain where, because we have so many non-native species, there's now 24% of the fish species there, freshwater fish species are non-native, 54% of the amphibians, 88% of the crabs and crayfish. 12% of the plants, and 13% of the bivalve mollusks. So we're dealing in Great Britain with a highly changed, a highly altered freshwater species community because globalization has transported all of these species there. If we look at the pathways of how those species have arrived, so along the x-axis here, the horizontal axis, we have different slices of time. These are each 20-year periods. And then up the y-axis, we have the number of established species that arrived during that period, and then the different stacks are indicated in the legend here by how they arrived. So we can see that over time, and especially recently, it's contaminants that have been dominant. So these are species that have been introduced accidentally as a byproduct of introducing other species, or as a byproduct of some other transport mechanism like ballast water. So those are the dominant ones at the moment. We can see that the ornamental introductions, the black, appeared to peak between 1960 and 1979 and may now be declining, although I've got to tell you that that last bar is for only 7 years. All the rest are for 20 years, so that last bar it's already grown actually since we published this work. It'll continue to grow. And one of the interesting things that comes out of this also is that stocking in Great Britain was quite important. That's the dark grey bars, but it's been virtually eliminated now. And that's a sign that in Great Britain, and this has happened around the world, that the management agencies that were doing the stocking, so this is of things like rainbow trout, which was moved from California to Great Britain, largemouth bass, again, moved from this part of the world to Great Britain. The management agencies have become a lot more enlightened about the problems from invasive species, and they've stopped this process of stocking. But as you can see, other things like contaminants, accidental introductions have increased by more than enough to make up for any shortfall from stocking. A little bit closer to home, this is the same sort of data from the Great Lakes. We can see that we have, again, this upward curve in the number of species over time. This goes back to 1840. We now have slightly over 180 species, non-native species, established, reproducing in the Great Lakes. And on average, we discover a new species every 28 weeks. So that tells you just how powerful these pathways are. They're still introducing a lot of species, and the number of new species is increasing. The rate of introduction is increasing over time. Okay, so to put this part of the presentation in context, we're introducing species at a very high rate. They're becoming established at a high rate, and it's strongly correlated to the rate of globalization, where I use globalization as shorthand to refer to increasing trade, increasing travel, these increasing connections that we have across the continents, across watersheds, across ecosystems. Invasive species have become one of the strongest drivers of biodiversity loss in all ecosystems, but especially in freshwater ecosystems, in rivers and lakes. And we have these very high economic, human health, and ecological impacts from invasive species, and those continue to grow as we get more species. So what I want to talk about now are some case studies, and what I'm going to try and do is to tie in sort of the basic background that I've just given you to some of the other themes that have been that have already been spoken about at the Teacher Institute or that are coming up this afternoon. And the first one is the impact of invasive species on human health, an example of that. And the example that I want to talk about is the Asian tiger mosquito, which, has anyone ever seen these things around here? Yeah, if you ever see one, you tend to know it. They're really big, and they have these, they look like stripes when you see them, although in this blown up photo they actually look like splotches. So this is a non-native mosquito to North America, which has only been here for, I think it's less than a decade that it's been known in North America. So you might be saying, are we talking about invasive freshwater species? This is a mosquito, it flies. Like all mosquitoes, it has an aquatic larval stage. So So these are the larvae that you see in water tanks or a bucket if you leave the bucket outside after it rains. So the Asian tiger mosquito are native to Southeast Asia, but they're now established and invasive in at least 28 other countries around the world, including quite recently the United States. They're big and they're aggressive. And as with a lot of mosquitoes, they contribute to the spread of a lot of these blood-borne diseases and viruses because they bite one person and then they bite another person, and you have the opportunity for the spread of a virus. In the case of the Asian tiger mosquito in the US, we're most concerned about the spread of West Nile virus, which is also a recent invader. And West Nile virus infects birds. These Asian tiger mosquitoes love to bite birds. And then they like to bite humans and horses as well. Horses are severely impacted by this disease. So they've really driven, in a lot of areas, they've driven the transmission and the spread of West Nile virus. And you can see this map here. They show up as purple here in Southeast Asia as the native range, and then the green is where Asian tiger mosquito has become established around the world. So we can ask, how have they spread? And the answer is this really weird example, this really weird truth that kind of floored me when I found out about it. But they're spread around the world in old car tires. And it turns out that the tire recycling trade is globalized. Southeast Asia generates a lot of old tires, but the recycling facilities aren't necessarily there, so these tires are exported. And they get exported with these pools of water, which every now and then contain mosquito larvae. So that's probably how they got introduced to North America and how they've been spread to these 27 other countries in these little pools of water in tires that are being spread around for recycling. So that's an example of how the globalization of this one really small trade has led to the spread of this invasive species, which in turn is promoting the spread of other invasive species like West Nile virus and having a really negative impact on human health. Okay, the next example I want to talk about comes from South Africa, where it was realized in the mid-1990s that invasive plants in South Africa were actually, they transpire. The invaders transpire a lot more water than native plants. Transpire is basically how much water the plant pumps out into the atmosphere as it photosynthesizes. South Africa is famously and very heavily invaded, especially by Australian trees. So the forests have a lot of these invasive species which are transpiring more water, which is less water that's flowing into the rivers, which is less water that flows into reservoirs to downstream communities. And freshwater invaders are also very important in this problem as well, because they can cover lakes and also increase the transpiration rate. So it's been estimated that the total South Africa water yield, so this is the total amount of water that's available to humans in South Africa, has been reduced by about 7% because of invasive plants. 7% is a lot of water, especially when you consider how much of that water can actually be gathered by humans and used as fresh water in municipal supplies. So South Africa has, over the last 15 years or so, had this very large program called Working for Water, which is basically a program where they send crews of people out to cut down these invasive plants and to get rid of them. And this has been really important, especially since the end of apartheid, because one of the great injustices, or certainly one of the great perceived injustices to black communities, was that the major landholders were white agriculturalists who had the rights to most of the water. So South Africa found itself in a situation where it had to start delivering more water to these black communities because they were demanding it because apartheid had ended. There wasn't necessarily more water available in the system. They still needed the agriculture, so they had to somehow find more water. So they established this Working for Water program in 1995, and it has these many benefits, one of which is it employs up to 30,000 people per year to head out and chop down these trees. And so far, they estimate that they've cleared about 1.6 million hectares which is a massive amount of land have been cleared of these invasive species, and they've had this very significant increase in water availability. So not only is it a good way to increase water availability, it's a very cheap way, especially compared to building new dams. Speaking of dams, and I know you heard about dams yesterday, so dams over the last 100 years especially have spread across the landscape, across the globe. There are many more dams than there were 100 years ago. And these can become really important sites for invasions because they're places that we like to introduce new species. Remember I said that species are more likely to become established if they're introduced many times in high numbers. Dams fill that function because we want to fill them up. They're these new ecosystems. We want to fill them up with all the species we want to be able to catch and to eat. They're also highly disturbed, which means that there's this specific suite of species that are very good at becoming established. And they're very similar. A dam in China is very similar ecologically to a dam here in the US, to a dam in Australia, to a dam in South America. So what we see is these same species that are very well adapted, in the same way that rats and pigeons are well adapted to living in cities. We see these species that move through ecosystems, gaining their footholds in dams, and then spreading beyond the dams. And this photo is from quite close to where I grew up, Eildon Reservoir. And you can see that as the dam level has changed, and this happens in dams all over the world, water comes in, it comes out, so the level changes. We get these very characteristic disturbed ecosystems with very little vegetation up the edge. So they're highly disturbed, so you have a suite of species that can survive. And one of those is the common carp. This is different to the carp we hear about in the news at the moment. But it spreads through these dams, it gets introduced repeatedly, and then from those dams it can spread into native ecosystems and cause all sorts of problems. And there are many other species that their spread is enhanced, their invasion is enhanced by dams. And the final example, I wouldn't be an invasion biologist if I didn't talk to you about Asian carp. So this is one that you may have heard a little bit about in the news lately. A few people have been talking about it. Some politicians are involved. And this has become a problem because, and the previous speaker spoke about this as well. In 1900, Chicago had this idea that putting its raw sewage into the lake where it got its drinking water from was a bad idea. And it turns out that Chicago was having huge, very high rates of typhoid at the time. So it really was a bad idea. The solution was to dig a canal that connects Chicago to the Mississippi River and to send our sewage west. Go that way, we keep getting our drinking water out of the Great Lakes. Now originally this canal, the Chicago Sanitary and Ship Canal, was too polluted to be a pathway for invasive species. Nothing could live in there. It had the effluent from Bubbly Creek, directly from our sewers. But as the Water Reclamation District has begun to treat water to a higher standard, it has actually become quite a strong pathway for non-native species. So I spoke about the zebra mussel. This is how the zebra mussel got from the Great Lakes to the Mississippi. Round goby is another invasive fish. We have the Asian carp species, which are moving through the system at the moment. And there are many other species stacked up on the Great Lakes side. I told you there are over 180 invasive species in the Great Lakes. There are many species on the Mississippi side, and over time, if this canal stays open, those species are going to continue to use it as a conduit to access other ecosystems. So the Asian carps, which people are worried about at the moment, are native to East Asia. They were introduced to southern fish farms, places like Alabama, Arkansas, and water treatment plants to act as filter feeders and to try and keep those water plants cleaner. Silver and bighead, two species of Asian carp, escaped into the Mississippi in the 70s and 80s. They've spread very rapidly north. They've gotten to very high population levels, and we now see them in the Chicago area waterways. They've moved up through the Illinois to the Des Plaines and now into the Chicago Sanitary and Ship Canal and quite possibly into Lake Michigan. And this shows the DNA results, which have been tracking them moving. And you can see the grey areas are areas where they have been previously found, which is pretty much the whole system. The yellow areas are areas where the DNA has been found just in the last few months, just this year. So linking this back to the idea that globalization is leading to these very damaging invasions. So silver carp, one of these species that we're concerned about at the moment, is native to East Asia. It was introduced highly artificially to the southern US to be used in water treatment plants and fish farms. It's been able to spread through the Mississippi River, a highly disturbed system, which is very conducive to the growth and spread of this species. And we now see it spreading through a highly artificial system, a canal that is not natural, that was dug by Chicago and Illinois in 1900 as a sewer, as an open sewer essentially. And it's moving towards the Great Lakes, where people are really concerned about the sorts of impacts that it might have. Okay, conclusions. These are my take-home points. I guess these are the points that if the students of Chicago could know anything about freshwater invasive species, I'd want them to know this. First of all, the invasion sequence. And this is a really important piece of biology and ecology to explain and to describe how species go from being elsewhere in their native range to being invasive and harmful in places like the Great Lakes. So they need to be introduced, they need to establish, they need to become invasive. I'd want them to know that very few introduced species become established and very few of those become invasive. However, because globalization is so strong, because trade and travel so strongly link these ecosystems, even though very few species make it through, we're introducing so many at the top of this sequence that a lot of species are becoming invasive. The total number of invasions of species is increasing. It's increasing faster than it's ever increased before, and the total harm from those species is also increasing. And invasive species have ecological, economic, and human health. So we're talking about freshwaters. Freshwater ecosystems are really strongly impacted by invasive species. And there's this big range of impacts. We have diseases that come out of these freshwater ecosystems, disease vectors that come out and that then infect humans. And we have impacts like reduced water availability, and I described that for the South African case. And I hope I've convinced you that freshwater invasive species are a large problem all by themselves, but they're also a problem that interacts with many of the other issues that are affecting freshwaters at the moment, and many of the other issues that you've been hearing about and will hear about at the Institute. Thank you very much.
We're good? Hello? Okay. We have plenty of time for questions, so who has a question for Dr. Keller?
Hi, what's the definition of a watershed, and what watershed are we in?
Okay, the definition of a watershed is it's any area where all the water that lands in that area drains to a common point. So if we think about the grand watershed of the Mississippi River, that would be any part of North America where if a drop of rain falls, it ends up at the mouth of the Mississippi River, flows out through New Orleans. So that's the definition of a watershed. What watershed are we in right here at the moment is an interesting question. Up until 1900, we were in the Great Lakes watershed, standing right where we stand now. If a drop of water had fallen here, it would have flowed east into the Great Lakes through the Chicago River, which used to flow east. We reversed the flow of the Chicago River so that a drop of water that lands here now flows into a stormwater, a sewer system, flows to the Metropolitan Water Reclamation District treatment facilities, from where it flows west to the Mississippi. So we used to be in the Great Lakes watershed, we're now in the Mississippi watershed. Well, the Mississippi flows into the Gulf of Mexico, but one wouldn't... Well, the Gulf of Mexico watershed would be made up of many thousands of smaller watersheds, of which the Mississippi is one.
it seems that the previous presenter, I guess, mentioned that the EPA has said that we have to clean up. We should be cleaning up the Chicago River and making it better. And we have incentive from the Asian carp. I mean, we have pressure to go ahead and eliminate that. Is that possible and realistic? Can we do that in time to stop the Asian carp, or can it work?
The answer is yes, we can do it in time. The next question you've got to ask is how much political will is there and how much does it cost? So what the Michigan Attorney General, and actually all the other states around the Great Lakes, have been pressing Illinois to do is to close the locks in the system. So just put in a hard barrier until a better situation is figured out. That has a lot of problems of its own, including, Chicago is built on the presumption that water flows west. If we close the locks, then the water can't flow west anymore, so we'd have some problems. But the answer is yes, we could do it if we decided to do it. So the Illinois EPA, through the Illinois Pollution Control Board, has been considering for a long time whether, and I think it's up to about 4 years now that they've been considering this, whether the Chicago water treatment plants should have to go to tertiary treatment. And we heard previously about what tertiary treatment is. That's to knock out as many viruses and bacteria as possible. The US EPA, the federal EPA, sent them a letter saying, we think you should. And that would be a prerequisite towards sort of longer-term separation of the Great Lakes and Mississippi watersheds, because the water probably has to be clean enough to go back into the Great Lakes, as it already does in Green Bay and Milwaukee. How quickly that can be done versus how quickly the Asian carp are moving is anybody's guess. But I think the answer is that yes, we could stop the Asian carp making it to the Great Lakes. Whether that will happen, I don't know. At a larger scale, we should see the Chicago Sanitary and Ship Canal, even if we forget all about Asian carp, we have a very large problem there of the transfer of invasive species. So at a larger scale, I personally think that we should be moving towards re-reversing the river. And I think that Josh Ellis is going to talk about that a lot more this afternoon, and he's a much more eloquent speaker than I, so you'll hear more about it. But he's of the same mindset as me.
Actually, I have a follow-up question on that, which is there a time difference between if the Asian carp actually gets into the Great Lakes system and when it becomes established, as you had on your different phases of invasive species, the introduction versus the establishment?
Yeah, you often see what's called a lag time to establishment, which is that when you introduce a very small population, which is presumably what would happen if and when the Asian carp move out of the Chicago River into Lake Michigan, you have a small population, and of course that has a very small growth rate. You have fewer females, as females drive growth rates. You have fewer females who are reproducing. So you tend to have a pattern where the growth rate is very low for a long time, but then it suddenly takes off. So we'd expect to see a lag time. That could be anywhere on the order of 2 or 3 years to several decades. We just don't know.
I'd like to thank you for your presentation, and I guess my question comes from, is there any known diet switching within freshwater ecosystems to these invasive species by native species? And if so, how does that play into the balance of ridding the invasive species but also conserving those that now have adapted to eating them?
Yeah, so the question is, can native species adapt to eat invaders? The answer is yes in a lot of cases. And that would be the reason that a lot of established species, or a lot of introduced species, don't become established, is because they arrive in an ecosystem where there are already good predators for them. So yes, it can happen, and it can happen over time as well as species behavior evolves. We even see in some cases that species morphology evolves. In Australia, there are snakes now that have evolved. Actually, it's kind of a paradoxical situation, but cane toad is an invasive species in Australia, and they have these poison glands behind their ears, roughly speaking. And if you're a snake and you eat a cane toad, then you can deal with a certain size of cane toad because you can deal with a certain dose of the toxin. So we're seeing snakes in Australia are evolving to have smaller head sizes so that they can only eat smaller snakes, so they don't get this high dose of toxin that kills them. So we see that sort of evolution over time as well. But one of the characteristics of many invasive species is that they're not eaten by anything. And Asian carp are a really good example of that. Asian carp grow extremely quickly. So fish are generally susceptible to being predated, to being eaten when they're smallest. Asian carp pass through that part of their life cycle extremely quickly. So they have this small window when they're vulnerable to being eaten by native species. And Asian carp also have this other impact in that they're filter feeders. So they filter out the very bottom of the food chain. So that food chain, the bottom supplies the next level and the next level and the next level and so on up. But they kind of cut it off at the bottom. So all those other species, which could be quite good predators of Asian carp, are all of a sudden cut off from their main food source. So their population numbers decline. So Asian carp both grow through the period when they're vulnerable very quickly, and because they grow so quickly and eat so much, they knock out a lot of the species that could otherwise eat them.
I guess the question is, are there any other evasive species that are harming the Great Lakes, or are we the only ones that are having this Asian carp come into the Great Lakes, or are there any other cities around the Great Lakes that also have the Asian carp?
We're kind of ground zero at the moment because of our connection to the Mississippi River. There are other smaller connections between the Mississippi watershed and Lake Michigan up in Wisconsin, and they will presumably become ground zeros too. But at the moment, the most likely way, the most plausible way for Asian carp to make it into the Great Lakes is through the Chicago River system. So we're really ground zero. There are many other invasive species in the Great Lakes that we're very concerned about as well.
I think we have time for one last question.
My understanding is that the Nile perch were secretly introduced by the government to help increase the fish stock in Lake Victoria, and that the cane toads were brought to help eat some sort of grub in Australia. And so yesterday someone said that every problem starts as a solution, and I wonder if there's been any sort of legal actions or legislations that have been passed after the fact to talk about doing studies to see what would happen of purposefully introducing new species to ecosystems?
Yeah, this is a huge issue. I think, can I summarize the question by saying who bears responsibility and how do we hold them accountable? In the case of Lake Victoria, the Nile perch was intentionally introduced. It has created a large fishery. If anyone's ever seen I forget the name of the documentary now, but I'll remember if anyone wants to watch this documentary. It's a great documentary which talks about how the Nile perch fishery has been essentially set up to supply European demand. So the fish are caught, they're processed on site, they're flash frozen, they're put on a plane to Europe. So all of that protein that was meant to come into the system for the locals just doesn't happen. In fact, the locals, they get the scraps from the fishery processing plant, which are the bones and the heads, which they make soup out of. To the best of my knowledge, no one's ever tried some sort of a class action lawsuit against the government in Africa, or the governments, because there are many countries that share Lake Victoria. So that would be particularly tricky. The cane toad was introduced to Australia by the government, just a spectacular disaster. It was very fashionable in the early 1900s to introduce cane toad because there was some... Darwin's Nightmare. Thank you, whoever gave me that, is the name of the documentary from Lake Victoria. It's a really fascinating documentary that will leave you incredibly depressed. But fascinating. But that's what documentaries are meant to do, right? The cane toad was introduced to Australia because there were some results from, so people had started growing sugarcane in Australia. There was this thing called the cane beetle, which was eating a lot of the sugarcane, reducing the crop. And there were some people who decided that, so the cane beetle came from South America, where it looked like the cane toad might be keeping the cane beetle in check. So they introduced cane toad to Australia. It turns out that the cane beetle lives roughly this high up a sugarcane stalk, and that cane toads can jump about this high. So it's quite possible that these things have never interacted. But the cane toad loves Australia, and it's gone nuts. People are spending millions of dollars at the moment trying to slow down its spread. Again, I've never heard of anything like a class action lawsuit against the government. That would be a tricky thing. It was introduced in the 1920s and 30s by a pretty small section of a small government department in Queensland. What people have begun to talk about is trying to hold the shipping industry legally responsible for ballast water invasions into the Great Lakes. This is really tricky because there aren't really any laws on the books that cover it, and it would have to be a class action lawsuit against the whole shipping industry because we never know which particular ship introduced which species. But I know that people have tried to pursue that. I believe it's more of a scare tactic for the shipping industry to try to get them to improve their practices. But yeah, that's about as far as it's gone. And I think I've well and truly run out of time. But I will be around for the rest of the day. Thank you all.
Thank you.